All right, cool. All right, so we got a test coming up. Basically, the idea here is we just finished chapter 9. So chapter 8 and 9 are kind of our intros to like geometry and proofs and angles and all that kind of stuff. So we're going to take that test early. Tanner. We're going to take that test early next week sometime, probably Tuesday, I think. So Tanner, do you have something relevant to say? Let's see what he has to say. Tanner, you want to say what's up?
I don't have anything relevant to say.
Okay.
It's not relevant.
Just a shout out from Tanner, everybody.
Hello, everybody. I hope you're all doing well. That's my shout out.
Awesome. Okay, cool. Okay, you can go ahead and mute your mic again. All right. Anyway, so yeah, we got a test coming up. So we need to get ready for that test. Now, I put in as an assignment like a really long math assignment. It's like 46 questions. But we're going to do this over the next few days. So we'll do this meeting. If it works out really well, we're going to we'll do another meeting on Friday, and we'll see if that helps. And then, like I said, we'll take a test earlier in the week. Tanner, all I can see is your face laughing. How do I get rid of this? Okay. All right. So I'm going to jump to the document camera here, and we're just going to go through it this way. Okay. So this might be a little hard to see. Whoa, 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 whoa. Okay. Does that look normal to you guys, or is that backwards?
That's normal.
Okay, sweet, cool, looks good. All right, and a little like my printer is kind of running out of ink, so we'll go through this. But this assignment you should pull up right now if you haven't already. So I'm going to give everybody a minute to do that. It's in Google Classroom. You can pull it up on like a separate window, or you can print it out, or whatever it happens to do. This is what we're going to be going through today. So get that ready, and we'll kind of come back in like a minute, and we'll start this. Just want to give everybody a chance to get that assignment ready. Oops. Sorry, Mike, I accidentally just sent you a private message that was supposed to be to Seth. Okay. All right. So you should hopefully have this in front of you, and if I need to, I'll read through this because, like I said, my printer kind of crapped out a minute ago. But the first few questions are just about axiomatic systems and Euclid's postulates in general. So the one that I wanted to kind of particularly go through, because we didn't have this in the book, are like the Euclid's postulates and the axiomatic system questions here. So the first one is about Euclid's fifth postulate, and basically the idea is if we know that this angle is 110 and this angle is 70 degrees, what can we say about these two lines? Does anybody have you can just type your answer in the chat if you know what's true about those lines. If this angle is 110 and this angle is 70. Anybody got that? That's right. Yep. Parallel. Parallel is correct. That's Euclid's fifth postulate. So if these add up to 180, they don't have to be 70 and 110, but if they add up to 180, then these lines are parallel. Okay. So M and N are parallel. Okay. All right. Number 2, fill in the blank. According to Euclid's fourth postulate, all right angles are. Anybody know that one? Shout them out in the comments. All right angles are. Anybody else besides Jake? That's true. All right angles are 90 degrees, but this is Euclid's postulate, and in Euclid's postulate, he doesn't say they're 90 degrees. He says they're all congruent to each other. So each right angle is congruent to each other right angle. Yeah, congruent, that's right. Okay, which of Euclid's 5 postulates would you be using if you use a compass to create a circle? So one of Euclid's postulates is that you can use any like segment and endpoint to create like a radius and a center, and you can make a circle. Does anybody remember what postulate that was? Yeah. Postulate 3 is correct. Number 1 was just like, basically you can, create a line that goes indefinitely in any direction. Oh, that was 2, excuse me. And then like a segment can connect any 2 points. That's like 1 and 2. All right, number 4. What is the name for the truths or rules or facts that are proven through logic and deductive reasoning? So things that we have to prove in an axiomatic system. We don't automatically have them, we have to prove them. Does anybody remember what those things are called? Things that we have to prove? Theorem, that's right. Theorem is correct. Also, Euclid calls these propositions. So if you put propositions there, I wouldn't mark it wrong, unless it was multiple choice, and that wasn't one of the options. But yeah, that's what we got there. Theorem is right. And what was the name for the common notion or the things that we don't have to prove? The things that we just kind of take for granted, the self-evident truths. Oh, yeah, axiom is one of the words we use there. That's what Euclid said. Yep, postulate's the other one. Okay, good. Okay, so that's kind of just like the intro to the axiomatic system that we talked about. Okay, the next few I'm going to let you guys do on your own because all of these definitions are in the book. And actually, if you look specifically at like 8.5 and 8.6, they have all those definitions in there. So you're going to have just a multiple choice or matching. One thing that I do want to kind of point out really quick is that some of these overlap. For example, like vertical angles can be congruent to each other, right? So be careful when you're trying to define vertical angles and congruent angles, because those definitions can kind of be similar. But with congruent angles, they don't have to be in a certain position or relationship to each other. So congruent angles are any 2 angles that have the same measurement, right? Vertical angles are congruent, but there's a little bit more to the definition. It's not just that they're congruent. There's also a certain like format they have to be in, and we know that's basically they kind of have to be like across from each other. So we have 2 lines that intersect each other, and we have 2 angles, and those angles form opposite rays, 2 pairs. So I kind of just gave you one of those definitions. We have 2 angles whose sides form opposite rays. Okay, that's vertical angles. Also, these guys are vertical as well. So I'll let you guys look up those definitions there. All right, truth table, and this looks pretty shabby, so let me darken it up for you. We got P, we got Q, we got not P, we got not Q, we got P and Q, we got P or Q, we have P implies Q, we have Q implies P, which is our converse, we have not P implies not Q, which is our inverse, and then we have not Q implies not P, which is our contrapositive. Now this is like a master truth table. We've done a bunch of truth tables, but we didn't do truth tables where we had like this many things in it. But actually that's like, okay, that actually makes it a little bit easier because we don't have to repeat some of these things. So remember that when we first start out in our truth table, we got our setup here. P and Q are just any 2 statements that can be either true or false. Having fun, Tanner? All right, good. So true, 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 false, false, true, false, false. Those are our options, okay? So what I want you guys to try to do real quick in the next, let's say 30 seconds, is see if you can get these 2 columns, the not P and the not Q. These are the negations of the opposites of P's and Q's. So I'll give you 30 seconds or a minute maybe to do that. You guys try to see if you can get that, and then we'll fill them in together. Okay. Let's see. I think I'm going to call on somebody. That'll be fun. Mercer, are you there? You in there, Mercer?
I don't remember any of this.
Okay, that's all right. Help me out here then. So what's the opposite of T?
F,
Yeah. And the opposite of T?
S,
Yeah. And the opposite of F?
T,
Yep. And the last one?
T.
There you go, man. Good job, Mercer.
Thank
Okay, false,
you.
false,
I did
true,
that
true.
all on my own.
Yeah, good job. Can anybody get not Q? Holy smokes, Ella, is your hair purple? Looks so cool. Okay, so this one should be false, true, right? Just the opposite. That's what the not sign is, negation sign. Okay, so that should be pretty good. Okay, this one is an and, that little symbol that looks like a Christmas tree or something like that. That's an and symbol, okay? And for an and statement to be true, the and statement is true when both of the other statements are true, right? So let me go back to my image because I can't see it anymore. There we go. So I look for these two statements, P and Q, and I think to myself, are they both true? In this case, yep. Okay, then the and statement is true. Are they both true here? Nope. Okay, so that's false. Are they both true here? Nope, so that's false. Are they both true here? Nope, so that's false. Okay, so there's only, in an and statement, there's usually only one true if you have, this combination, because it's only true when both of them are true. Okay, let's do the or. Looks like an A for and. That's right. Yep, that's how I remember it too, Jake. It looks like an A for and. The other one doesn't really look like an O for or, but you just remember it's the other one, right? So yeah. We also sometimes call this one a conjunction and this one a disjunction. Remember those words as well. So the or is true when either one of them is true, when at least one of them is true, right? So P or Q, so we look at the P or Q, the P and Q columns and say, is at least one true? Yep. Is at least one true? Yep. Is at least one true? Yep. Is at least one true? No. So that one's false. Okay. So that's how we did the or. Okay, now the last four here are all conditional statements. Notice they all have like the arrow in them. Okay, so in this situation, this is kind of like the contract idea that we talked about with, we use Tanner as an example, we use Ella as an example in period 8. But the idea is the only time you get a false from a conditional statement is when you have a T going to an F, right? So if you have a true, like the true means like the contract is in force, and F means you didn't fulfill like the second part of the contract. So we talked about like mowing lawns or babysitting or whatever. So in this case, we're looking from P to Q in that order. And so we need to look at the P and Q columns. And what we're looking for is, do we have a T going to an F? So do we have T going to F? Nope. Okay, then we can say that this is true. Do we have a T going to an F? Yeah, we do. Okay, that's the one that's false. That's what happens when like Tanner mows my lawn and I don't pay him, right? Or Ella babysits and I don't pay her. That's the problem. If Tanner mows my lawn and I pay him, great, everything's cool. Okay. And then the next one here is an F to a T, which kind of seems like maybe it should be false, but that one's actually true. Again, the contract here is like Tanner didn't mow my lawn, but I still paid him. Okay, well, he's stoked. There's no problem there. He's got 20 bucks in his pocket. The conditions in the contract weren't violated there. And then false, false. So this is like Ella didn't babysit and I didn't pay her. Okay, cool. Well, nobody's really worried about that. The contract, it wasn't violated. Okay, that's the conditional. So for the rest of these, all we got to do is we got to just look in the direction that this indicates and the columns that it indicates. So Q to P. Okay, well, here's Q and here's P. So we just need to look in this direction. And again, they're all going to be true except for the T to F. That's the only one that's not going to be true. So looking from P to Q, right? Or sorry, from Q to P, excuse me, Q to P. So T to T, okay, that's fine. F to T, that's fine. T to F, that's our problem right here. And then F to F. So what we have is true, true, false, true. Okay, the only time we have a problem with when we have a conditional is when we have a T going to an F. The letters tell us what column to look in, and the arrow tells us what direction. So we want to go from Q to P in there. Okay. The next two, we're actually going to shift and look at different columns, because this is not P implies not Q, which means we need to use these two columns, the not P and the not Q column. So that's what we're comparing. And again, we're looking for T to F is the only thing that's going to give us an F, right? So we were looking from not P to not Q. So that one's fine. We're going in this direction, right, this way. That one's fine. Okay, there's our problem. There's the issue, right? Not P to not Q, that's T to F. That one's false. And then T to T is fine. Okay, real quick, what do you guys notice about these two columns right here? Think about it, type out your response. Yeah, they have the same truth values, right? And if they have the same truth values, that means they're logically equivalent. We're looking at these two right here. Now, these two are opposite of each other, definitely, or like the kind of the F is in the wrong spot, right? So the converse and the inverse have the same truth value, which is kind of interesting. Okay, again, the Q to P, switching the order, that's the converse, and the negation of each is the inverse. Now what we're doing is both. We're doing not Q implies not P. Okay, so again, we have to go back to our not P and not Q columns, but the direction is not Q to not P. So we're going backwards. And again, we're just looking for a T going to an F. Everything else is going to be true. So we're good. Uh-oh, there's the problem. T to F. So that's going to be false. That's fine. That's fine. Okay, notice that these two guys are also logically equivalent, right? The original statement, the original conditional statement, and the contrapositive have the same truth value. P, they are the opposite of each other. Just look at P to Q. Yeah, oh yeah. Right, the opposite direction. Okay, so let's kind of stop there for a minute and see if we have any questions on the truth table. So I think it was Jackson that was saying that you can raise your hand. So if you have a question, you can either do a little hand raise, or you can type your question out onto the right, and we'll just see if we're good on truth tables. So I'll give you a couple minutes to look at that and make sure you're good before we move on. Okay, I haven't seen anything yet, so I'm going to assume everybody's good. If we need to backtrack, throw something up in the comments or do a little hand raise, and we'll go back. But that's kind of how I think I'm going to do it for your. Well, I don't exactly know how I'm going to do your test. It'll probably be multiple choice through Google Forms. We'll see how it goes. But if we have to combine more than one thing in a truth table, that's totally fine. You can just keep adding columns as many times as you want. So. The next section here kind of builds on that. We talked about converse, inverse, contrapositive, that kind of thing. So all we're going to do is take a statement, and we're just going to switch the order of the hypothesis conclusion, or negate the hypothesis conclusion, or maybe both. So here's our conditional statement, right? Our if then. If I don't have homework, then I'm going to the park this weekend. Okay, so I don't have homework, we're going to label as T. And I'm going to the park this weekend, we're going to label as Q. Okay, so for the converse, what do we need to do? Anybody know? You can either unmic or you can type your comment.
Swap the P and the Q.
Yep, that's right. Yeah, we need to swap P and Q. Thank you very much, Jake. So what we're going to do is we're going to say if Q, then P. So if I'm going to the park this weekend, then I don't have homework. Okay. And that could be true or untrue. It doesn't always match. If this original statement is true, it doesn't always follow the converse is true. We've seen that before in some of our like theorems and stuff. Sometimes the converse isn't necessarily true. Okay, what about inverse? Does anybody remember what we need to do for inverse? If you want it, you can unmute yourself and shout it out or type it.
Not P and not
then
Q.
Q.
That's right. Yep. Good job, Ella. Not P implies not Q. So we're going to negate each one. So if not, I don't have homework, right? Or if I don't have homework. Then I'm not going to the park this weekend.
It's actually if I do have homework, then I won't go to the park
That's
this
right.
week.
If I don't not have homework, right? Yeah. If I do have homework, good call, Ella. Yeah. Then I'm not going to the park this weekend, right? Because we're negating something that's already kind of negative, right? If not, I don't have homework. So if I do have homework, yep, good call. All right, and then the contrapositive, what do we do there?
If you're not at the park in the weekend, then you did have homework.
Yeah, we're going to negate and switch, right? Good call. So we're basically going to take this inverse and switch the order, or take the converse and negate both, either way. So if I'm not going to the park, this weekend, then you could say I do have homework, or I did have homework, or something like that. This weekend. Okay, so it seems like you guys are pretty good on that. So hopefully some of this stuff is starting to ring some bells and sound familiar, which is good. Good job. Okay, the next little bit, we're going to talk about just the difference between inductive and deductive reasoning. And so if you remember from like the video I made from you, there's two sides. There was like the detective and there was the weatherman, right? And the detective or the lawyer uses like the rules and the definitions and the laws and the clues, and he comes to specific conclusions from general facts. And the weatherman was the inductive guy, and he looks at a lot of examples and lots of different past history to be able to come up with predictions, which we call conjectures. So that's kind of the difference here. So number 3 says observing data or many specific examples to find patterns. So observing patterns, then make general conjectures or predictions. Which one is that?
Inductive?
That's inductive, that's right. Inductive has to do with looking for patterns and then extending those patterns, okay? Also, remember that inductive reasoning went from specific to general. So you take a few specific cases and you try to make a general rule out of it, basically. The next one is using general definitions, rules, and facts to construct a chain of reasoning that will end with a logical conclusion. Okay, well, that's probably got to be deductive. But we know that by definition, that's what deductive reasoning is, right? It's go general to specific. We'd use definitions and rules. So our axiomatic system is our deductive reasoning system. We start with those axioms and those definitions and those constructions, and we build stuff from there. And this week we started talking about new theorems. We actually proved a few theorems this week from the stuff that we already had. So now that we gathered all of our, all of our rules and laws and facts and stuff like that, we can start putting them together. So that's our axiomatic system. All right. Oops. I think I skipped a page here. Number 2. Yep, there it is. Okay, now the next one, this is the one that I think people had the most trouble with. Not everybody struggled with this, but this detachment and syllogism. So we did like a few different days on this, and hopefully that was helpful for you guys. But the main idea here that is, and I think the thing that's really hard about this is we're so used to true false. We're so used to, is it true or is it not true? And I'm trying to figure out if this statement is true or false. And what we're doing in this is we're not looking at true or false. We're only looking at does it follow a specific logical structure. So when we reach a conclusion, that conclusion could be sound or not sound. Like it could be a true conclusion or a not true conclusion, but that's not really what we're trying to decide. What we're trying to decide is, does it follow a logical structure? So you could have something that's bogus that still follows a logical structure. And that's really what we're looking for. Does it follow the logical structure? So let's take a look at 25 here. So detachment has a very specific structure. All right. There's 3 statements, and there's whenever you do a detachment. The first statement is a conditional. A P implies Q. If it's sunny, then I go to the park. Okay. The statement 2 is just another case of P being true, or a specific case of P being true. So today it is sunny, right? Well, today is a specific example of it being sunny, right? So what would be my conclusion here if today it's sunny?
Then I'm going to the park.
Right, then today I'm going to the park, right? Yeah. And that's it. If it doesn't follow that pattern, it's not a detachment. So a lot of times what I'll do, just to kind of like, test to make sure that you know what you're doing, is I'll switch statement 2 and 3. So what it needs to do is it needs to go PQ, PQ. And if it doesn't go PQ, PQ, then it's not a detachment, okay? So let's take a look at the next one. If I drive more than 3,000 miles since my last oil change, then I will get an oil change, okay? So if I do this thing, if this thing happens, then this thing happens, P and Q. Okay, let's look at statement 2. Today I got an oil change. Is that a specific example of P being true? That's Q, right? That's Q. So today I got an oil change. I know it's kind of hard to see. Sorry. So what we have is P implies Q and then Q. So this definitely cannot be a detachment because it doesn't go PQ, PQ. This is going PQ and then Q, right? So it doesn't follow that structure, and we're going to say that it's not a valid example of the law of detachment. So we're going to say invalid. What we have here is we actually have the converse, right? If this is P to Q, and then this is Q, and then this is P, what we're saying is, well, if this P to Q is true, then Q to P must be true. And we don't know that that's the case because the converse isn't always true, right? So that's what's going on there, right? This is not necessarily true. So this, we're going to say invalid. Okay, and the examples you used in your quiz, the 3 choices you had was invalid, law of syllogism, or law of detachment. And again, it's basically like, if it follows the structure, cool, you can say it's this thing. Anything else you have to throw out and say it's not detachment. Okay. All right, let's see where I'm at here. Okay, just trying to like line my thing up the right way. Okay, syllogism. Let's see if we can make a conclusion. So syllogism is basically your transitive property, but for conditional statements. So the first statement is like a P to Q. The second statement is a Q to R. And then the third statement will have to be from P to R. It'll connect those two. It'll bridge those two. So if I get up early, then I will go on a walk before work. Okay, P implies Q. So P, Q. Now, in order for it to be syllogism, the very beginning of statement 2 has to be the same as the end of statement 1. They have to match up. So if this says something that's not, I go on a walk before work, then it definitely isn't syllogism. So that's our first test. It has to start with Q. The second statement has to start with Q. It does. If I go on a walk before work, okay, that's Q. then I will drink a protein shake. Okay, well, that's a completely different conclusion that we've seen before. So we're going to label that R because that's the next letter of the alphabet. So P implies Q, Q implies R. The conclusion has to be P to R. So can somebody shout out what that's going to be?
If I get up early to go to work, then I will drink a protein shake.
If I get up early, then I will drink a protein shake, right? Okay. Now you might say to yourself like, well, I don't know if that's true because I don't know what your habits are. I don't know if you drink protein shakes. I don't know what the connection is between going on a walk and drinking a protein shake. That doesn't make sense to me. Well, that may be true, but we're not looking at, again, whether the statement is true or false. What we're looking at is a logical structure. So assuming that the first statement is true, which we don't know, or could be yes or no, and assuming the second statement is true, then the third statement has to be true. So it's not necessarily about true or false. It's about, does it follow this structure? Okay, and the structure of a syllogism is P implies Q, Q implies R, and the last one will be therefore P implies R. You skip the Q altogether. Okay. All right. Let's see. Okay. The next one here is just to determine if this is a syllogism or not. So determine if the conclusion reached is a valid example of the law of syllogism. Okay, so is this syllogism? That's kind of the idea. If a person likes bananas, then they like strawberries. Okay, so P and Q. All right. If a person likes strawberries and they like apples. Okay, so that's Q and R. Okay, and then statement 3, the conclusion is if a person likes bananas, which is P, then they like apples, which is R. Is that a valid syllogism? Throw a comment in, say whether you think it's valid or invalid.
Invalid.
Why do you say invalid, Mike?
Because instead of going from R to P, it goes from P to R.
That's what it's supposed to do. P to Q, Q to R, and then P to R. Right? P to Q, Q to R, P to R. So it looks like it follows the right structure. So it looks good. Yeah, now you might argue like, well, just because somebody likes bananas doesn't mean they like strawberries. True, that may be the case, but we're not looking again as if this is true or false. Let's see, will R also imply P? Not necessarily. If P implies R, will R also imply P? Not necessarily, because again, that's a converse, and we don't know that the converse is always true. So what we're looking for is, does it follow this pattern? P to Q, check. Q to R, yep. So therefore, P to R. Yep, that's exactly what it needs to go. Yeah, so R to P, we don't know. If this is switched, we can't say it's a valid syllogism. If this second statement is switched, we can't say it's a valid syllogism. That's all we're looking for is, does it follow this structure? So sometimes when we look at these, it's easy to say like, I'm gonna try to like wrap my brain around this and see if I can figure out if it's true or not true or valid or not valid. And the reason why we do it this way is because sometimes we can get some statements that are so complicated, it's really hard to determine if they're true or not just by thinking about them. So the whole idea is to map it out to something that you know has to be true. And if it maps to that same structure, then you know it's going to be valid. That's also the same reason for using a truth table. So for example, let me go back real quick. Truth table. Lost it. Anyway, sorry. So on the truth table, like if you ever do like circuit diagrams or something like that, or you're building a circuit and you want to know if it works, or if you ever like, you know, if you're a lawyer or something and you want to see if something is logically equivalent, you can actually just construct a truth table and see if it's two things are logically equivalent. So what we're doing is we're learning tools to be able to take something that's complex and break it down into pieces and analyze it like mathematically so that we don't have to like rely on our own judgment. We can just say, does it match the pattern or not? And if it does, then we say it's syllogism or detachment. Okay. So those are the 4 for that one. And again, the structures are pretty simple if you can remember them. The detachment goes P to Q general and then P to Q specific. So the number 25, right? P to Q and then P, the conclusion is Q. It's just a specific case of Q being true. So P to Q specific, general, and then P to Q specific. And then the syllogism is basically like a transitive property. So remember, if you have if A equals B and B equals C, then A equals C, right? That's how the transitive property works. The difference is with equality, we can like switch the order and stuff. We can't switch the order when we're talking about conditional statements. But this is kind of the statement we want, but instead of A's and B's and C's, it's P's and Q's and R's. So P implies Q, Q implies R, therefore P implies R. That's what we want there. So if you have those structures, you compare them to those structures, you're good. That's all you need. Okay. Tanner, did I answer your question okay? That it doesn't necessarily follow that R implies P because that's the converse statement. We don't always necessarily know the converse is true. Tanner, are you still there? Okay, maybe he took a break. Anyway, all right, so the next little bit is going to be some algebra stuff. So if you're an algebra guy, then you're stoked on the next little bit because this is not too bad. You just basically have to set up an equation and you have to use a fact to do that. So let's run through a couple of these. I think we got about 20 more minutes here on our meeting. That'll give us maybe close to halfway through. And then we can come back and look at some proofs on Friday if we need to. Okay, so number 2, two angles form a linear pair. Okay, what do we know about linear pairs? What's the crucial piece of information that we need to know about linear pairs? Unmute and shout it out or type it in the comments.
Don't they add to like 180 or something?
Right, that's true. So there's two angle relationships that have to do with 180. One is linear pair and one is supplementary. Can anybody distinguish the difference between supplementary and linear pair? Because they're kind of similar, but they're not exactly the same. Maybe want to venture a guess on that?
Linear pairs have to be in a certain position.
That's correct. Yeah. Linear pair is like they actually have to form this straight angle, right? The definition in the book is that their non-overlapping side or their non-common side forms opposite ray, or in other words, they form a straight line. So a linear pair is two angles that form a straight line. And because of that, that measures have to add up to 180. So if two angles are a linear pair, they're also supplementary, but that doesn't work the opposite way. Just because two angles are supplementary doesn't mean they have to be a linear pair, okay? And that's kind of an example of a converse not necessarily being true. So in this case, the idea that we need linear pair means needs a couple things. Number one, it means they're adjacent to each other and they form a straight line. Number two, they have to be supplementary. And since we're talking about angle measures, we're probably dealing with the 180 idea, right? So we know these two angles have to add up to 180. So when I set up my equation, it needs to be 4x plus 10 plus 3x minus 5 equals 180, right? The angle measurements have to add up to 180. Okay, now from here we can solve for x. And what we want to do is we want to find both the angle measures. So what you're going to do in the next maybe couple minutes, I'll give you a couple minutes, is to solve for x. That's step 1. And then once you have x, plug it back into each of these two so you can find their measures, and they hopefully should add up to 180 if we set this up right. Okay, so go ahead and do that. Take, maybe we'll do like a minute and a half or so. You guys can set that one up and solve it. And then we'll check. Okay, so x is 25 is right. So that's what we get when we solve for x. Now what we need to do is take that 25 and plug it back in here and here so that we can find the angle measurements. And when we do that, we get 110 and 70. And those indeed are supplementary, right? You add 110 to 70, you get 180. So that's kind of the check. So it looks good. Yeah, so the three answers here is find both, or actually it says find both their measures. So we want these angle measures. This is the starting point. We have to find x equals 25, but then eventually we want to get down to the 110 and the 70. Okay. Any questions on that one before we move on? I'll give you a few minutes to think about that. You can verbalize it on the mic or type it if you want to. Okay, looks like no questions there. All right, the next one here, same kind of idea. We need to basically first figure out what is the crucial piece of information here. So angle 1 and angle 2 are vertical angles. Okay, well, again, we know a couple things about vertical angles. First, we know what they look like position-wise. Vertical angles are when two lines like cross each other. They make these angles that are across from each other, and these are vertical angles. Okay, so we know what they look like. We also know the fact that we proved last week is that vertical angles are congruent to each other. So the crucial piece of information is that angle 1 and angle 2, since they're vertical angles, they have to be congruent to each other, which means their measures are equal. So if their measures are equal, what we can do is we can say 4x plus 7 equals 71 minus 2x. Just set them equal to each other. So in 29, we added them together and made them equal 180. That's because they're linear pairs, they're supplementary. This is a different relationship. In this one, they're congruent to each other. So we set it up that way. Let's go ahead and solve again, and then let's plug it back in and see if we can get those angles. So take, maybe 60 seconds or so and see if you can get those. Is that right? I feel like I did something wrong here. Did everybody else get a decimal on this one?
That's what I got.
Okay. So x equals 10 and 2/3 basically, or 10.67. So it doesn't come out nice. That's okay. Let's plug them back in and see if we can get the right stuff. So 4 times, oops. And then, okay, so it looks like one of them is 49.67-ish. And then the other guy, same, well, it'll have to be the same, right? Because they're congruent. So about 49.67 either way. And since we get the same answer when we plug them back in, they're supposed to be the same answer, right? They're congruent. Yeah. So depending on where you round, if you round to 10.7 and then you put them in, you're going to get something that's like kind of slightly different. So that was a little bit tricky because of the decimal, but if you kind of take it out a few decimal places and plug it back in, you should get something pretty close to that, which means they're congruent, which is kind of a good check there. Okay, so pretty much an algebra problem, but we have to start in geometry and figure out what do these key terms mean? How do they apply? Okay, let's do a couple more of those. Okay, these are probably the two of the hardest questions on here, so it's good that we're going to get to these. Okay, two angles are complementary. One angle measures 26 more than twice the other. Find the measure of both angles. Okay, that's kind of a mouthful. What does complementary mean though? That's the key. That's what we need to unlock before we can move on.
The two
Yeah,
angles
90
equal 90 degrees.
Right. Yep, good call. Two angles equal 90 degrees. So we're going to add two angles together and it's going to equal 90. Okay. Now the hard part is figuring out how to write them. So we got one angle measures 26 degrees more than twice the other. Okay, well, let's make one of those angles x. Okay, so one angle we'll call x. The other angle is going to be 26 more than 2 times the other one. So how do we write that? Well, 26 more than will be plus 26. 2 times the other one's called x, right? So that's how we do it. So this right here is one of the angles, and this right here is the other one. So 26 more than 2 times the other one, and x is the other one. So we call the other x. 26 more than twice the other is 2x plus 26. So that's kind of a tricky one. You gotta have to like remember what like more than and twice, you know, how do we write those out? But this is what you get. Then we can combine like terms. So 3x plus 26 equals 90. And now it's just a 2-step equation. Okay. And we want to find the measures of both angles. So we have to go back and we don't just want to find x, we want to find both. So we can subtract 26 from both sides, which means 3x is equal to 64, I think. Let's double check that. Make sure I'm not going crazy. Okay, good, that checks out. And then divide both sides by 3. And we get another decimal. 21.33, is that what you guys are getting? Good, okay. So that's one of them. The other one, we have to figure out what it is by plugging it back in. But remember, the other one is 2x plus 26. So we got to take that 21.3333 thing that we got, and then we're going to have to, can you guys still hear me okay? I got a little warning. Okay. And then we have to divide. So let's see. Mike, I think the reason why you're getting 64 is because you're subtracting these two, but since they're on the same size, we got to combine like terms, not subtract. So this should give us 3x. And then move this over, be 64. So 3x equals 64, I think, on this one. So that's going to be x, and then we plug it in. Oh, you're talking about the second one? So I got 68.66 or 67. Okay. Oh, yeah, right. Yep, good call. Okay, cool. So yeah, x is equal to 21.33. That's the first angle, but we got to find that second angle. Is there another way, or would there be another way to find this second angle without plugging it back in to this piece right here? Yep, you're right, Grace, or excuse me, Ella. It's close because we rounded. It should add up to 90. Now, if we used fractions like 68 2/3 and 21 1/3, it would add to exactly 90 degrees. The issue here is just that we rounded. So our approximations make it a little bit less true. But your point is well taken that they should add up to 90 degrees. So what we could do is if we found this first angle and we know they're complementary, to find the second angle, we could just do 90 minus that angle, and that should give us 68.67. So let's try that out. If we do 90 minus the first one that we got, now again, if you round, it's going to be a little bit off, but whatever. Right, you get that 68.67-ish. So, yeah, depending on how you round or where you round, you might get something a little weird, but 68.67 and 21.33, those will add up to 90. Okay. So that's how you do that one. Then the keyword is complementary. Okay. Let's do this. I want you guys to try number 32 because it's kind of similar. Okay. See if you can set it up. But the keyword here is supplementary. Okay. So see if you can set it up because that's the hard part, and then we'll solve it together. Okay. I'll give you a couple minutes to do that. Okay. So this is what the equation should look like. So we got one angle measures 16 degrees less than 6 times the other. Okay, well that means there's two angles and they have to add up to 180. So supplementary means they add to 180. So that's where I get that. Okay. Now I called one of the angles X. Okay, so there's one of them. The other one, the other one is we got one angle measures 16 degrees less than 6 times the other. So 16 degrees less than means subtract from 6 times the other one. So here's angle 1 and here's angle 2. Add them together, they have to be 180. You can break that down into pieces if you want. You can just call one of them X and figure out what the other expression is. But that's kind of the setup here. So when you combine like terms, you should get 7x minus 16 equals 180. We want to solve for x and then plug those guys back in. So we'll add 16 on both sides. 7x equals 196. X equals 28. Okay, and then from there, we're going to plug it back. Well, if we want to, we can either plug it back in here to find the other one, or we could subtract from 180. So we know that this is one angle. They have to add up to 180. So to get the other one, we could do 180 minus 28. This gives you 152. Also, that should work if we plug it back in. So 6x, 6 times 28 minus 16 should give us the same angle. So 6 times 28 minus 16. Okay, we get 152 either way. So those are the two angles, 28 degrees and 152 degrees. Cool. Is your video really bad? Okay. You guys having video problems? Okay.
There's video and microphone problems, at least on my end.
Okay. Well, let's see. We're pretty much out of time anyway. So this is kind of what I wanted to find out from everybody. I'll go back to this mode. Okay. So this is kind of what I was thinking, and I just want to get you guys' feedback. We can do class kind of like this, but there's a couple issues with that. Of course, the first one is can we get a good connection, right? Is the internet at our place and your place and all of our places good enough for us to kind of connect real time, which obviously could be an issue. The second issue is that we may not be able to meet all at the same time. So we have a pretty good group, which I'm actually pretty surprised. I wasn't anticipating having this many people, but I'm glad that we do. And the problem is we're not getting everybody. So that's the question, Mia. The question is, do we do another meeting like this, or do we keep doing it in video format? If I do a video, I think we can rely on the audio a little bit better. I think that you guys can watch it on your own, at your own schedule, at your own time. You can also speed it up if you need to. You can skip over some stuff. You can rewind and watch it again. So that was kind of my initial thought, is that if I give you guys videos to watch, then you can kind of pace yourself, do it at your own pace. With that though, obviously we have some people who are, like, we lose some people sometimes because if we don't have like a set schedule, then it's sometimes hard to discipline yourself. So I want you guys all to just sound off in the comments and say what you prefer. Do you prefer like a live video meeting, or do you prefer to do it via like videos? Are you okay watching videos? So everybody just comment there and see what we do. See what you prefer. Okay. So it looks like it's either, videos. I think a lot of people prefer videos, but maybe live once in a while just to get everybody together. I think that's probably a good suggestion. So what we'll do here then is let's go ahead and schedule another meeting for Friday. We'll do it just like this again. In addition to that, I'll post some videos for you with this worksheet, and that way if you missed anything, or if it was too fast or whatever, you can still go back and watch those. And we'll try to do a little bit of both. It's hard for me to do both like all the way because it takes an insane amount of time to make videos. I don't know if you guys have had any experience with that, but just uploading to YouTube sometimes can take a couple hours. So anyway, we'll do some more videos. I'll post some videos for you. I think that's the best way to go about it because, like most people said, learning at your own pace, being able to go back and watch it again, the audio being clear, I think those are good benefits. But I also think that there is maybe something worthwhile in having an optional sign-in just so we can kind of talk. So if that sounds good to everybody, we'll kind of go forward with that. If you have any other comments or questions or whatever. Yeah, I know, maybe you should. Yeah, you can go to the restroom, Jackson. Then I think we'll do it that way. So if you have any other comments or whatever, shoot me an email and we can kind of adjust from there. I'm also available for personal, like one-on-one meetings if we need to do that. So get in there, watch those videos. I think they're designed to help you get through your homework. And if you have any other questions, shoot me an email. But it was really good to see all of you guys' faces. Hope you guys are doing well and not going too crazy. Last comments, last thoughts.
I have purple hair. You think we're not going crazy? I have purple hair now.
I love it. I think it looks awesome.
We're all
I want to dye my
I
purple.
buzzed my head, so I called it. My mom called it the quarantine cut.
Quarantine cut. Nice. Anybody else have some wild and crazy hair going on?
Quarantine cut, Jackson. I'm gonna join you in that quarantine cut. Mock my words. It will happen.
This is the only time I've done my hair like in 2 weeks, so you're welcome. Okay, guys, I'm gonna end the meeting. Thanks for joining. You guys are awesome. Be safe out there. Social distancing. Love you all.
Bye. Oh.